Hello everyone. I'm gonna cut the introductions short because I know the lectures are pretty long and I want to cut you guys as much time as you can. I'll save you guys as much time as you can. So today we're gonna continue with differential equations. Um, this is just a recall. If you want to read it, go ahead. This is separable equations. Okay, so this is only we're talking about first order equations, first order differential equations, in which the expression dy over dx can be factored as a function of x times a function of y. Now you're gonna ask, well, why should we do this? And we're gonna go into it here and you'll see why exactly we need to do this, and I'm gonna go over each question here, then I'm gonna erase it, put the solution, and then go next. All right, so the first one is this, and what this is saying is we want it, so this is y prime, your y prime equals to your dy over your dx. So they're saying we want it like this, equals some function times some function. One function is in terms of x, one function is in terms of y. Now, in order for us to separate this, we have x over 1 minus root y. To separate, this is the same as saying x 1 over 1 minus root y. This is multiplication. As you can see, this is our equation 1. This is equation 2. This doesn't have any x in it. This doesn't have any y in it. And in the next step, we'll go into why we need to do this. And it's something with integrating it. Okay, so this, as you can see, we separated into two. This, you could make this as your f of x, and you can make this as your g of y, or your g of x and your f of y. Same thing. This works just because you can separate them. We're going to go into examples where it doesn't work. Oh, all right. So that's solution number 1. Solution number 2, we have ln x. This one is the same. You know how I brought down the x and I multiplied it? This one will become ln x plus x all over ln y plus y, and then you bring it down so it becomes ln x plus x times 1 over ln y plus y. So you see now it's split. This is in x terms, this is in y terms. That's a dub. We take those. All right, let's delete this. Now I'm gonna choose a different color because why not? All right, so now we have y sine x. You see, as we're going, some of them aren't as obvious, I would say. I mean, this should also be a little bit obvious for you, but if it's not, that's fine. Here, what we can do is we can factor out the y's, and what we'll get is y sine x plus x. And you see again, terms of x, terms of y, that is f of x and g of y, which works. All right, I'm not going to delete this actually because I have enough room for the next one. So this works. Right here, what do we have? So we have x3 plus 1 plus y2 x3 plus y squared. I'm pretty sure for this one in specific, there's multiple ways to do it. You can, so here, if you look at this, you can pull out your y squared. The other way is you can rearrange it and pull out an x cubed, I believe. We'll go with this method because it looks easier. So we have x cubed plus 1. That's 1, right? Plus, I'm going to pull out my y's. Because this is going to be, I don't need the bracket. I'm going to pull out the y. Now I get x cubed plus 1. As you know, when you pull this out, it doesn't go away. You still have a 1. Because technically you're dividing by y to the 2. Okay, so now I can pull out again my x cubed plus 1 and x cubed plus 1. What I'll get is x cubed plus 1, right? And then because I pulled it out, this is times this. When you pull it out, becomes 1 plus, when I pull this out, I'm left with the y squared. Now you see we have two equations in terms of x and y, so this also works. All right, let's get rid of this stuff and go to the next equation. Here we have y equals x plus y. We can't really do anything to this to separate it in terms of f of y and g of x. There's literally nothing you could do. This will stay as one function. They're not separable. You see, this is multiplied. How you can't multiply these are added together. And so this you cannot go. You cannot do it. Next one, ln of x. This has an identity, ln. So ln of x, y is the same, is equivalent ln of x plus ln of y. And this is actually the same as x plus y. Like, I'm not saying it's the same value, I'm saying it's the same idea. So you see, you can't really separate them, just like we can't before. And so that's also a no. You cannot do it. There you go. Okay, so for our next one, we have y e the sine x. And the funny thing is, sometimes students see these, and they're like, it looks complicated, and what's the identity for Euler, whatever his name is? What's the identity? The best way you could think about this is if you have x to the power of 3, all right, times x to the power of 2, what this really comes to is x to the 3 plus 2, which gives you x to the 5, right? So this, if you take these in terms of Euler, so x is e, 3 is your sine x, plus, that's your plus, and 2 is your cos y, you can separate these in these terms, which is e to the sine x, which is our 3, times my e to the cos y. That's an identity. I mean, you could look, like, I mean, basic. I'm pretty sure if I gave you this, you would understand it. But if I give you this, you'd be like, what am I supposed to do? Let me look at the identity, and it's actually the same thing. And so what you could do here, you have y e to the sine x times e to the cos y. And since this is multiplied by this, which is multiplied by this, you can technically separate these and rewrite it into e sine x times y e cos y. I just took this from here and put it in the middle. It's all multiplication. It's the same thing. And so now this is one term. This is second term. That actually does work. All right. So that's this one. Let's get rid of. Oh, sheesh. All right. Yeah. So this one works. Our next one is ln of x to the y. And yeah, don't let this scare you off again. If I gave you like, let's see, e to the y equals x to the y, and you want to isolate for this y, what you'll do is you'll ln it, because when you ln it, it comes down. So what happens is you get y ln e. Ln e is just 1, so it cancels out. That's the whole point. Equals, now you have y. Here, obviously you have to ln this side too. When you ln it, you bring it down, so the y comes down, and then you'll have ln x, right? So this is just you lnning both sides. That's what it looks like. And so when you really do it, when you use the identity of ln, when you apply ln to this, the y comes down, and you'll get ln x. And now you have this in terms of x, and this in terms of y. And so that works too. So far, so good. Capiche, capiche? All right. So I am going to go down to the next one. And solve this. You may leave your answer as an implicit defined function. This is where I'm going to go into why we're separating them. This is the next step after you separate them. And so when you take this, let's change our color to something red. This is important to remember, and apparently red grabs attention. So anyway, so remember how earlier we said y prime equals dy over dx. So I'm going to write this out early. And the other thing is, now let's take this part and turn it in terms of x times y. A function of x times a function of y. All right? And so this is the exact same thing as we had earlier here, or we had earlier here where x is at the top, y is at the bottom. You can just bring it down. I'm going to do it up here. So this is the same thing as 5 plus sine x times 1 over your 3y6 plus y plus 1. It's the same thing. And so now you have, your f in terms of y, and you have your g in terms of x, or vice versa, g in terms of, or, f in terms of x, or g in terms of y. You decide this. It doesn't really matter. So now if we take this and sub it into here. Well, not sub it, but replace it because these are equal to each other. And this one is equal to this. So now if we place both of them in, we'll get dy. I'm going to zoom in because this is a long equation. If I can get enough space. So I have dy over dx. So I just replaced it from up there. Equals this one, what we had up here, which was, we have x to the 5 plus sine x. Okay, so that's our first equation. Times 1, 3y6 plus y plus 1. Now what I want to do, if you want to integrate this, whenever you wanted to integrate something, if you remember, it was always x dx or y dy, t dt, and when you did u sub was u du. You want to turn this in these terms, where it's dx with x, y with dy, t with dt, and so on. And so that you saw this and you understood it, I'm going to delete it. And how would I do that here? Since this is multiply, you see, if this was divide and I took it the other side, what I'll get is u minus du, let's say, or x minus dx. You cannot integrate this. We never integrated something like this. We always integrated x times your dx. Sometimes it was like x times negative dx, but it was never minus. That's why if it was something like this, you cannot. So if I had dy over dx and I equals x plus y and I take y to the other side, I'll get dy minus y. I cannot integrate this. And so that's why you want them in terms of multiplication or division. Okay? And so when we go here, let's remove this and separate them. So our dy stays, we'll keep it. I'm gonna divide this whole term by itself. Okay. And so what happens is this whole thing cancels out. I'm gonna divide this side by 2. Okay. We'll keep 1 over dx here. I just took it apart. This 1 over dx. Took it apart. I took the dy apart. And now what I'm gonna do is this whole thing, because I divide this side, I have to divide this side. So divided by 1 over the whole thing, which is 3y6 plus y plus 1. If you're confused what I got, this one is just the whole thing, 1 over, right? And so now I got this. When you have a division over a division, you can actually flip and multiply. All right. So this is equivalent to 3y6 plus y plus 1 times dy. You flip this and you multiply it by the top. These are equivalent, so I'm going to rewrite it. All right. So what I have is I'll have 3y6. Oops, let me make that more to the power of 6 plus y plus 1. All of this dy, right? I still have my 1 over x, so this whole thing is over dx. That didn't go away. I just put it aside so I can show you the simplification of what I did with the 1 over. All right, and now this is actually equals to x5 plus sine x. All right, I'm going to use a different color to separate these. Okay, these are 2 separate. There you go. So after I've simplified it, now the next step what I could do is I could multiply by dx and multiply this side by dx. So then I'll get 3y6 plus y plus 1 dy. Don't forget this is multiplying by dy equals, since I multiplied by dx, so this is multiplied by dx. This cancels out with this. You have to multiply this by dx as well. You get x to the 5 plus sine x dx. Now that I have this, I can integrate. So what I can do is I can integrate both sides now. I'll integrate this and I'll integrate that. So coming to the side, let's integrate. So the first integral, I'm going to use a different color. The first integral, I'll highlight it here. And I'll highlight this in a different color. There you go. If I go to the side here, I'm going to use the same color so you guys can connect the two. I have the integral of 3y6 plus y plus 1 dy. And then when you integrate this, I'm running out of space, so I'm going to zoom in more so I get more space. Okay, so if I want to integrate this, what I'll do is I can separate this. So it'll be integral of this plus the integral of this plus the integral of this. Right? So the integral of 3y to the 6, you'd add 1, and then divide it by what you add. So this will come, y to the 7, and then you divide by that 7. So it'll be 3 divided by that 7, y to the 7, plus you add 1, there's an existing one, you add 1, and then you divide by the addition. So it'd be y to the 2, and then divided by that addition, plus that one just becomes y. Your dy goes away because you've integrated, but what you do get is a plus c. Never forget your plus c. Now on the other side, what I have is x to the 5 sine x dx, and this is a plus, right? Now if I want to integrate this, what I'll do is add 1 and divide, so it'd be x to the 6 divided by 6, and I will get minus cos x, and that's my integral plus c. All right, now what you can do, these are called arbitrary c's, which means they're a constant value that can take over any number. They can be 1, 2, 3. Why can it take any number? The reason being is because when you integrate, remember how we said this will give you a family of integrals like this, like an infinite amount of integrals, and that's why the c can take over any, because like these like one beside the other, and so any number c becomes is a different type of function, the family of functions. And so this c can be any number, and any number you put it will give you a different type of function. And so what we can do is we can combine the c into one equation. If I can find my pen. Yeah, so we can combine this into one equation, the c's. And so what we can do is 3 over 7 y to the 7 plus y squared over 2 plus y equals what do we have? X to the 6 over 6 minus cos x, right? And now we have this. We can just do at the end of it plus c. And you're like, oh, why do we do a plus c? Because I just combine them. A c can be any number. So I just combine them into one c. So you have here c1 and this is c2. And I did like, let's say, I just did c1 plus c2 equals c. And I just replace that with just one c instead. It's an arbitrary number. Don't worry about it. You could do this. It's fine. All right. So that is our next step. So after you split them, so you see how I first split them. Where was it? The split. This is the split. After you split, you just integrate. And they literally said here, leave it as an implicit defined function. And this is an implicit defined function. And oh, they actually mentioned here, technically upon integrating, we will get c1 on the left and c2 on the right. However, we can combine these into a new constant c. Okay, so far so good. Now we're going to do the second example. What do we have here? We have e, I don't know why I'm rewriting it. Let me zoom in. Okay, so what can I do here to get it in terms of like we had it before, which is y prime equals some function. Right now we're not splitting it into g of x and f of y. We're just having it. So y prime equals a function, just like we had up here. You see how we had y prime and some function that is mixed with x and y. So that's fine. So let's turn it in these terms. What we can do is we can take the x to this side. So this will become, we'll keep this the same. I haven't played with these yet. I'm going to take x to the other side. Now I get minus x. Now what I could do is divide this whole thing by this whole term, right? Or what I could do is if I want to save time, I can just divide it by this term, okay? But I'll do step by step so you guys can see it. So what I'll do is I'll divide by e to the x squared y. That cancels out these two, and this comes here, right? So when my equation looks, I know this looks like a mess, I'm gonna rewrite it. So this actually equals y prime equals negative x all over e to the x squared y. Now replacing this with dy over dx, we get dy. Actually, do I have space on the side? Oh, I did. Nice. So replacing it, this will be dy over dx equals negative x all over ex to the squared y. Now we gotta split it, right? We gotta get the in terms of y on the left and in terms of x on the right, or you can have in terms of x to the right, to the left, and then in terms of y to the right. However you want to do it. It's just for us here, it's easier to have y on the left, because all we have to do is if we multiply by y, these two cancel out. This cancels out with this, but then we also have multiply by y on the other side, or oops, multiply by y on this side. So then what we'll get, I'm gonna continue this over here. So what we'll get is y dy over dx. I'm trying to show every step, right? And now what we do, we can just multiply by dx. So we'll get y dy equals negative x all over e to the x squared dx. Okay, now we can integrate. So I can just integrate here and integrate here. Now when you integrate your y dy, you'll only get, you have an like you have a 1 here, and then you add 1 to it. It becomes 2, and you divide, so this becomes y to this y squared over 2 equals. Don't forget your plus c, but I'm not gonna write it because remember how we combine it into one constant. So I'm not gonna put it there now because we're gonna combine it into one constant at the end. And so what happens here is let's see, how do we integrate this? We can split this into 2 parts. So I'll actually integrate this separately here. Yeah, I'll put this in brackets. That's some ugly ass brackets, but you get the point. Okay, so this we can integrate, we can split into negative x times 1 over e to the x squared dx. Now what we can do here, we can do a simple u sub. So we can make u equal x squared. So that means my du equals 2x dx. All right, now I can divide by 2, divide by 2. So what I'll get here is du over 2 equals x dx, which is exactly what I need. All right, I mean, actually, I didn't even have to take this out. I don't know why I did. I guess it was easier to look at like this. But anyways, so now we're gonna substitute the u in. So so this u will go here, and this here. This x dx is the same as x dx, right? So what we'll get, I'll take the negative out. The negative will go outside. And what I'll do is I have now 1 over e to the u, and we'll have du over 2. Okay, now this 1 over 2 can go out, so we'll have negative 1 over 2 integral of 1 over e to the u du. Okay, so now it's pretty simplified, and when you integrate e to the u, it stays the same, but this is 1 over e to the u. This is a simple. So this, when you integrate this, when you integrate e to the negative u, what happens is you will have still e to the negative u, except you would multiply it by the derivative of the top. The negative stays, the derivative of u would just be 1. So what you'll get here is you'll get negative 1 over 2, negative, because that negative is multiplied, negative, so this is also multiplied, negative e to the negative u. Now this cancels out. We'll get 1 over 2 e to the negative u. And that's the integral of this one, is right here. So writing this out, we will get 1 over 2 e to the negative u. But don't forget, we'll sub this into our u. So what we'll get is this is x squared. And don't forget our constant c. Okay? Now what we can simplify this a little bit more. So we'll have, I'll go down for more space. I have y squared over 2 equals 1 over 2 e to the x squared plus c. Okay? Now the next step is to simplify this further in terms of y. Remember before, it was an implicitly defined function. And we had like multiple y's, so we couldn't get it in terms of y. But when it comes to this, we could. So how would we get this in terms of y? Here's what we could do. We could multiply this by 2. So we have y squared equals 2 times 1 over 2e to the x squared plus c. Okay, so nothing special. I multiplied the left side by 2, and I multiplied the right side by 2. And since this 2 and this 2 is here, so this cancels out actually. So what we'll get is y squared equals 1 over e to the x squared plus c. We can square root, and then now we'll get y equals the square root of e to the negative x2. I just raised this up, and I put the negative plus c. And that would be your answer. Okay, I hope it wasn't too confusing. This I believe this is also in lecture. She did do this example. I mean, this is her lecture, so you guys have the solution. That's why I am gonna now delete it to have more space for the next question. Right? But it's simple steps. All you gotta do is first get it in terms of y prime equals something. Okay, then you separate. So you see, first we got y prime equals something. Then we turn the y prime into dy over dx. Then we had it in the equal sign. On one side is a y, and on one side is the x. Whether it's left is y, right is x, or the other way around, doesn't matter. Okay, sorry about that. Then after you've had them, you just integrate, and after you've integrated, you isolate for y. So we're gonna do this one more time. I don't like green anymore. I'm gonna use black. I feel like black is nice. Okay, so we have here y prime. Oops, I'm gonna actually zoom in to have a little more space here. We have y prime minus yx. So what we can do is we can just straight out take this here. So we'll get y prime equals yx to the 7. This is a pretty simple one. We'll have dy over dx equals our yx to the 7. Then we can, what can we do? We can divide by y, and we can multiply by dx. We'll have dy, we divide by y, so this will become 1 over y, right? We still have our dx, but I'm going to multiply by dx, so dx will go up here. There you go. Now we have this, we can just integrate normally. Integrate this side, integrate that side. The integral of this side will be ln of y. And the integral of this side will be x to the 8 over a. Right, now you isolate for y. How can we isolate for y? We can raise this to e, and then when you do that, you raise this to the e. So this will cancel out. You'll get your absolute value of y. Don't forget your arbitrary c. Okay, so we have this 1 over 8 x to the 8 plus our c. Okay, because this is supposed to have a plus c here. All right, so we raise them. Now, remember the from earlier we had sine x plus cos, plus cos y, and we could split them apart. We could do the same thing here. So we'll have a y equals e to the c, and then times e to the 1 over 8 x to the 8. Okay, now we can turn this into one constant. Let's say constant c, because remember, arbitrary number. This is not a variable. This is a constant. E is a constant, 2.7 something, and it's raised to the constant. So we can make this whole thing a constant. All right. So now we have y equals c e to the 1 over 8 x to the 8. Now, since this is a plus minus, but we're only taking the absolute of y, we can assume this is only a positive number. And so we can drop these because our c can only be positive now. And so what we can have here is our final solution is y equals c e 1 over 8 x to the 8. Okay, so that would be your final answer. You could change in the lecture. She changed it with k, but we're changing it with c. So you could this can also be k, just so you guys aren't confused. Okay, this is the same thing. After this, I believe we are gonna start figuring out how can we find this constant. And it's pretty simple. It's nothing too complicated. All right, so going to the next section. This is an application problem. The best thing with application problems, if you guys go to physics, you always write your knowns and your unknowns. And so here, if you read this, we have at 10:07 p.m., some secret agent was dead. Was a martini shaken before this? You see, like, this is useless information. You can scratch it out. We can only get the important information. Room temperature is 70. So actually, I'll highlight this in a different color. So we have 70 here. We have 10:07 here. Martini warms from 60 to 61 in 2 minutes. So from 10:07 to 10:09. If the agents are always served, so if the martini is always served at 40, what was the time of death? So we're looking for time. We can assume that the temperature change is governed by differential. So they give you an equation. That's nice of them, little bitches. Where t denotes time. All right, and so these will tell you what each variable means. And so here we'll write what each variable is since we have some information. So we always have a start and an end. So there's a start of the murder and there's the end of the murder. And so there's a start and an end. So here we'll have a start, and the start, this whole thing starts at 10:07, and at 10:07 the room temperature is constant 70. I'm gonna write that on the side here. Whereas this object TS is the room of the surrounding. So TS is 70. TS equals 70 degrees Fahrenheit. This is constant, it doesn't change. The room temperature doesn't change. All right. So at 10:07, it says here it warms from 60 to 61 between 10:07 to 10:09. So at 10:07, it's at 60, and at the end, at 10:09, it goes to 61. Okay, and so the start of the time is 0, and the end of the time is 2 minutes. 2 minutes, it says it here, and also if you do the time difference, is 2-minute difference. All right, now what we have is dt over, I'm gonna zoom in, so if you guys have this on the side, write it in some of your notes or something. But I'm gonna zoom in so I have more space. So I have dt over dt equals, we have k t minus ts. Now we said ts never changes, it's a constant, it's always 70. So I'm just gonna plug that in. dt over dt time equals our constant, capital T, minus 70. So far, so good. But what we want, like earlier, we want to split this into one variable on the right, second variable on the left. Just like if we had this dy over dx, and this was our y, we want the y on the left, and we want our dx on the right. How can we do this? One way we can do this is we can divide by the whole thing. So we can divide by this whole thing, and we bring it on this side. So we'll have 1 over, or to save some space, we have dt all over t minus 70. Okay, and that would equal, we're going to take dt on this side, so the k stays, and we have dt. Now, just like we've been doing the whole time, we're going to integrate. So integrate this and integrate that. All right, so when we integrate, I'm going to use black. This is 1 over t minus 70. The integral of this would be ln. So you'd have ln of t minus 70 equals, and this is a constant. The constant goes out, so the k stays. dt will just leave us with t. All right, so far so good. Now what we can do is, since we have some points, we have a start and we have an end, and we have all these things, don't forget we do have a constant here, so we're not done. Remember how we have to isolate for our t, just like we were isolating for our y? We have to do the same thing here. Okay, so we raise it to the e, and we raise this to the e. So we'll get t, so absolute of t minus 70 equals, is just repetition of what we did just before this. And so what happens is, we have our plus c here. Okay, and then this splits into two things. So this splits into e to the c and e to the kt. This thing, we can represent it by, what do you guys want to represent it by? Or I'll just keep it at c, I guess. I'm not sure what the teacher represented it by. I'm going to keep it at c. Okay, so, and since we know this is plus minus, but we're only taking the absolute, we're not going to take care of the minus, we're only going to take care of the plus. And now we have t minus 70 equals our constant c, e to the k, t. And you realize we have actually two constants that we have to find here. Okay, and we will find them in due time. So here we'll have t equals, we're going to take this to the side, so we have c now, e to the k t plus 70. Mission accomplished. We did get our first equation, and we're using c as our constant. And up here, we go to the right. Up here, we know at the start, when at t0, okay, our temperature of the martini is 60. And we know at t 2 minutes, our temperature of the martini is 60. So we can actually plug these into the equation and find our two unknowns. The first one, I'm trying to remember because I already did this a couple of minutes ago. And I'm trying to remember if the first one, you know what, we'll just do it and see what we get with. So we'll sub this into here. So what we'll get is, I'll zoom out so we could see clearly. 60 is our t equals c e. Oh, that's, yeah, now I remember how it happened. So our k here is unknown, but our t is 0. So this becomes times 0, which turns this whole thing into 0. And e to the 0 is 1. So this whole thing becomes 1 plus 70. So what we get is actually 60 equals c plus 70. And you bring 70 to the other side. So now you get 60 minus 70 equals c. And so negative 10 equals c. And that is our first constant. Now you can sub that in. So this is our equation, don't forget. And so I'm gonna go up here to my second. So I'll take this. All right. And so my second part, so our equation now becomes, since I found my c, which is negative 10 e to the k e plus 70. Now I can sub in my second 2 points and find my k. And so my t is 61 equals negative 10 e k to the 2 plus 70. Now let's isolate. 61 minus 70, negative 10 e k 2. I hope this is clear. I'll zoom in. Okay. 71 minus 70 is negative 9 equals negative 10. I'm just rewriting this. Divided by 10. So now we'll get 9 over 10. This cancels out with this when we divide, which equals, so actually I'll delete this so you don't think that it was a positive. Yeah, now what we have is e to the k2. What we can do is we can ln both sides. So now we'll do ln 9 over 10 equals k2, because this cancels out with ln. And so what we'll have is ln 9 over 10 over 2 equals our k. So far so good, nothing too complicated. So now we can actually rewrite the whole equation in those terms. So since we found our k, I just went up so I can remember the equation. I'll actually write the equation on the side here. Our t equals, so we'll continue this here. Our t equals negative 10 e to our k was 1 over 2. You can probably put this in your calculator and get the number, but I don't have my calculator on hand right now. I'm just going to write out the whole thing. And this is all multiplied by t plus 70. I know this looks like a mess, but don't forget, we're not done the equation yet, because what we're looking for is time when he died. And one thing we know up here is that the temperature when he died, so you see, if the secret agent martinis are always served at 70, so we know he was first served the drink at 40 degrees Fahrenheit. And so we can use that and find exactly what time, because it says next to him, martini got shaken before the secret agent could stir it. So what happened is, as soon as they served it, he died. And so we can see when he died, because we know the temperature of the drink was 40 when it was served. And so how long did it take for it to get to our, the temperature where we caught it, which is 61. And so the difference then, what we could do is, now we have -10, a 1/2 ln 9/10. T is what we're looking for, plus 70. Let me separate these. And so now you can 40 minus 70 equals, -10. E is just normal math, nothing too special. Now you can also divide it by 10. We can do 40 minus 70 divided by -10, which equals E, and so on, dot, dot, dot. I'm not going to continue it because this is from now on. I'm pretty sure it's on the lecture, as well as you guys should know how to do this anyway. So I'm not going to continue it, but I just wanted to show you guys the thought process. Now we have a couple more application questions that are all the same, especially these 4 are so similar. All right, so actually I am going to start with these 4. Or should I start with the top one? Let me see the top one here. This one is actually pretty easy, because this one they give you almost everything. So they give you a couple of values here, so you don't even need to read this. It's just a bunch of stuff. But they give you a bunch of values here, and they give you an equation, right? So you just sub it in. What can I do? This thing, I don't even have space for this. But yeah, I don't think I'm gonna do this exercise, because what you do is basically you'd sub everything in, isolate for one of them, integrate, and you'd get your solution, right? So and your solution, you see, they give you these 2 points, and so you get 0, you sub in, and you sub in 0 for that one, and you get your solution. All right, and they also have the answer here, so you should be able to confirm. I'll go through this one though. So the way you can think about these is pretty simple. You do the same thing. You know how I had dy over dt, or sorry, dx? For this one, what it tells you is, okay, so let me read through it. So it contains, I'm underlined these, so it contains 300 liters. In the 300 liters, we have 7 grams of water. The water contains water contains salt enters the tank, so we have 8 grams per liter enter the tank, and we have 5 liters per minute. Okay, and then roughly through the mixer strain rate, how much salt? So it exits at the same rate, at 8 grams per liter, 5 liters per minute. Actually, maybe not 8, because we have different concentration, because we have that 307 grams initially. So how much water is the tank after t minutes? So what you can do, because this is, you're looking at the difference between 2 things, which is difference between time at 0 and time at some time, like time at 10 minutes, let's say. So what you can do is we have D. I'm going to use A because that's what she used, just to keep consistency. And what I'm going to do is dA over dt. All right, this is just like your dy over your dx equals some function. And what is this function going to be? So what we want is the difference between the rate in and the rate out, right? Because here it says the solution is kept thoroughly mixed, drains from the tank at the same rate. How much salt is in the tank after t minutes? So we have some time, and how much salt after that time, at the end of that time. And so what we can do is rate in minus rate out, right? So we have rate in minus rate out. When that happens, how much do we have? What's the difference? So that's why we're minusing the rate in minus the rate out, and that leaves you in the middle. And just like the same I said in the other lecture, I believe, you have A and you have B here. Let's say this is like X distance, and this is like Y distance. Then the difference between them is my X difference minus my Y. So same as my X minus my Y. Okay, so rate in minus my rate out. Now the tricky part for this is figuring out what's the rate in and what's the rate out. So here, I mean, it tells you the water contains So we know the rate in is 8 grams per liter. That's how much goes in. And 5 liters per minute times 5 liters. Oops, I don't know why I wrote the L there. 5 liters per minute. This is my rate in. Now you think, oh, well, how did you figure this out? Well, I know I have 5 liters per minute. That's my rate in. But how much salt do I have in that 5 liters per minute? I have 8 grams per liter. So 5 times 8, that will give me 40 liters per minute. Well, sorry, not 40 liters, 40 grams per minute. Right? Because this is in terms of salt we want, not in terms of liters. And so that's why this cancels out and you'll get 40 here. Minus the rate out is the same, except we don't know our concentration, because when you enter is 8 grams per minute, but when you exit inside the water, we have 7 grams already per 300 liters. Okay, so our rate out, we're going to say A, which is our concentration, divided by how much water there is. And this is in grams, times the flow out. So you see, this is the same concentration. You see, this is L, that's G. So it's just we don't know the concentration, right? Because this tells you the initial concentration, but it doesn't tell you the concentration as the water is pouring in, because the concentration changes. Because here, this is pouring in 8 grams per minute. And so that's why we keep this as unknown. And so we multiply this by the rate out, which is 5 liters per minute. It's still the same. And how do I know this? It says the solution is kept thoroughly mixed and drains from the tank at the same rate. Drains, same rate. Okay? And so these two cancel out. 5 divided by 300 is 60. And so we'll have here 40 minus A over 60. And then here we'll have dA over dt. Now I know the prof left it here, but I am going to go more into it. So to give you guys the solution, I'm not going to go for the rest of them. I'm just going to go for this one so you guys get an idea. And so here, if I zoom in, since I already have the equation, which I have dA over dt equals 40 minus A over 60. Now, the same thing we've been doing before. You want to have your y on one side and your x on the other side, or in this case, your A on one side and your t on the other. And so what I'll do is I'll keep my dA, but I could divide. So this is the same thing. Yeah, I could divide by the whole thing, or I could just divide by one thing, but actually I'll just divide by the whole thing. So dA divided by 40 minus A divided by 60. Okay, and this will equal us dt. Now what I can do is I can integrate, right? So what we'll have here, I'm going to reduce this a little bit, so I have a little bit more space. Okay, so when I integrate this, this is just ln of 40 minus A over 60. And that will equal t, as our integral of dt is just t. All right. Now we gotta leave A on one side. How do we do that? Raise it. So this will be, don't forget your plus c, by the way. Okay, so we'll have, we'll raise it to the e. So now we'll have 40 minus A over 60 equals, we have t, so this will raise as well. And but remember how we said this c, we can split it into e to the t times e to the c, which turns into one constant. So what I could do is I'll take this. Oh, I highlighted the whole thing. There you go. Okay. So what I'll do is this times c, which is just my constant. All right. And now we just take this to the other side, times it by 60. So I'll continue down here. So we'll have, what do we have here? I'll take 40 to the other side, so that's e to the t. We'll keep my c in the front. Minus 40 equals negative A over 60. I'll take 60 to the other side, so now we have c e to the t minus 40. Multiply it by 60. And then this minus, also, I'm going to take to the other side. So right now, keep it. Minus. Now, when you multiply in, 60 times 40 is 2400. So we'll have c 60 e to the t minus 2400. And since we have an a here, if I take it to the other side, this becomes minus and this becomes plus. So far so good, capiche? To rewrite this, negative 60 c e to the t plus 2400. Now, to solve for my constant, how can I solve for my constant? It tells me at time 0 or at, sorry, not time 0. We're not dealing with time here. But what we're dealing with is a, so what is this in terms of? So we have a in terms of time. Oh, this is actually in terms of time. My bad. Yeah, that is in terms of time. I don't know why I thought not. So a in terms of time is some salt a, right? And so what we could do is a at 0, at time 0, equals 7. So in this bucket, before we start, we have 7 grams. It tells you a tank of 300 contains 7 grams of dissolved salt. So at time 0, our salt is 7 grams. That's our concentration. And so what we can do here, we can plug them in. So I'm going to continue down here. I'm going to delete all this, so make sure you're paying attention. So we have 7 for A equals, I'm going to zoom in, equals negative 60. My C, we don't know it. My E, my T is 0 from up here. And so plus 2400. This turns into 1. Now I have C equals negative 60. C plus 2400. Okay, now my only unknown is C. Take this to the other side. 7 minus 2400 all divided by negative 60 equals C. You'll get your constant. You sub your constant back in into this equation, and then you'll get your full equation. And if you sub in any time, it will tell you how much concentration there's in the water at that time. All right, so this is the only question I'll go into this much length. The rest of them, I am just gonna do the setting up of the equation. All right, so here, what do we have? We have 1500 we start with. We can ignore this for now. This is the same as your 7. This tells you your, A at 0 equals 20. That's what it tells you. Forgive my writing, please. But this is what this tells you. So I'll delete it for now because I'm only doing the equation, right? And so what we have is this fresh air enters the rate at a rate of 1200 feet cubed per minute and forces the smoky air out. What is the smoke content as a function of time? So we're going to start same thing, dA over dt. And then we have rate in minus rate out. All right, so I'm going to say here, actually, no, I'll do it on the side. Rate, and I'll zoom in even more. Okay, so my rate n equals, we have the concentration at the beginning, how much smoke is coming in, times how much air is coming in. So the smoke in the beginning, this is fresh air. So the smoke coming in is 0. We don't have any smoke coming in. Times how much air is coming in, which is 1200. So how much is smoke coming in? 0. There's no smoke coming in. That's why this is 0, right? You see, earlier, we had salt coming in. So this was some number. But if this was pure water, then this will be 0. And you'll think, why is this 0? Because if this had salt, right, and we have a number here, doesn't matter how much time you got, you'll take an infinite amount of time to get to a concentration of salt here to be 0. If not, never, because the same rate is going in as the same rate coming out. But in our case here, there's fresh air coming in, so eventually we'll have a smoke concentration of 0. The smoke content will have no smoke content anymore. So that's why, because there's no smoke coming in, it goes to 0, because eventually this whole integral will go to 0. Okay, so my rate out is equal to how much smoke I have. So the smoke I have here is some amount of smoke. I actually don't know how much smoke I have, divided by the room. Okay, times the flow out. So because we have a rate of 1200 in, So air's coming in. There must be some air going out, or else you'll have now a bomb of just air, compressed air in a room. Doesn't make sense. So common sense is this has to be some air out. That's why there's a rate out. And so you times it by the same thing, which is 1200 feet cubed per minute. This cube and this is a cube, it cancels out. So now what we'll have is we'll have 1200 A divided by 1500. 15,000, sorry. And so that was my equation, is a negative. And so our dA over my dt equals 1200 A over 15,000. And don't forget, this is a minus. So we're going to keep the minus here. And our initial A at 0 is 20. And we get that from here because it says initially at time 0, you have 20 parts per million of smoke. And so now you can go through what we went here, and you can forget this for now. You can isolate for your A. The only way you can isolate is divide this whole thing. Actually, no, you don't have to divide the whole thing. You can only divide the 1200 by this, and you take your dt up here. You'll have 1 over 15,000 dt. Integrate both sides. Sub this in to get your constancy, and that's your integral. Now, for this one's a little bit different than the other one because the rate in is not the same as the rate out. And so, suppose, same thing, dA over dt equals, we have rate in, rate out. So, rate in equals to the concentration times the flow. So, what does this say? Suppose we have 7,000. This is the beginning. We don't need this. We're looking for the rate in. The faucet that brings it in. Right here. That's what we're looking for. If we add pure water, so we're adding a pure water at a rate of 2, and add water containing 0.6 kilograms of salt at a rate of... Okay, so what this tells you is we have two faucets. One gives us pure water, and one that gives us salted water at 9 liters per minute. So our first rate in, how much salt do we have? 0 times the water, L, 2L over minute. This whole thing, I can't write, Jesus. This is minute, right? So this turns to 0. That's my first one. Just like we had here, it turns to 0. And then my rate out, my second rate in is, so usually what you'd have is you'd add these together. We're doing it separately, then we're going to add them. So now we have 0.6 kilograms kg per liter times it by 9 liters per minute. So 9 liters per minute. Okay, so this will cancel out and we'll only get 0.6 times 9 kilograms per minute. That's my rate in. Plus the 0 here. My rate out. Okay, my rate out just says here, and we know that the water flows out at a rate of 11 liters per minute. Okay, so my rate out is we have 11 liters per minute. However, what's the concentration? We don't know. So that's A over how much water there is, which is 7,000. So far, so good. I hope you guys are enjoying these lectures, because I am. Okay, so that's that. Now, when we sub it into this equation, rate in, rate out, my rate in is 0.6 times 9 kg per minute minus my rate out, which is 11A divided by 7,000. And so all you have to do is do this multiplication, and then you'll get some number. Let me do it real quick. Okay, so we got 5.4 minus 11A over 7,000. Okay, and this is dA over dt. You isolate them just like we've been doing. But then the question is, what's your A at t equals to? And so what it says is at the beginning, when A is 0, our salt, suppose we have 7,000 liters of water with 0.5 kilograms of salt. So if we have 7,000 liters and we have 0.5 kg every liter. So if we multiply these two, we'll get how much salt we have per 7,000. And so when you multiply these, you should get 3,500 kg. And now you use this to find your constant. Okay, so first you isolate and integrate, then you'll get some constant, and you'll use this to solve for that constant to get your actual function. Because if you don't do this part, you'll get a family of infinite functions, and that won't help you do nothing. Okay, and so that is the lecture number 2 of introduction to what were we learning? Jesus, I forgot. Differential equations, right? Anyways, see you guys later.